a special limit. Now, here we have a unit circle, and in that unit circle we have these triangles. It's a very important limit, this one. Okay, now, in this triangle OAB, this is side 1, this is side 1 because it's the radius of the circle. So the area, using half AB sine C, is half of 1 times the sine of theta. So that gives us half times 1 squared times sine theta, which gives me sine theta on 2. Now we know the area of a sector equals a half r squared theta. So again, we can see the radius is 1, so this becomes just theta on 2. Now in this triangle here, the triangle OAC, we can see this height of this triangle, h over 1, is equal to the tan of theta. So h equals the tan of theta. So from that we have that the height, there's the base, that's half the base times the height, which is tan theta, which is tan theta on 2. And we know that this triangle here, OAB, is smaller than the sector OAB, which is smaller than the triangle OAC. Therefore, we can say that sine of theta on 2 must be less than theta on 2, must be less than tan theta on 2. Multiplying throughout by 2, that won't affect the inequality signs, we get sine theta is less than theta, which is less than tan theta. Now when you turn these upside down, the inequalities will change the other way around, because you change, if you flip 2, that'll be 1 over 2, which will be less, and so on, right? Here's an example. If I had 2 is less than 3, therefore a half must be greater than a third. And because all these are positives, they won't affect the inequality sign. So now we have this result. 1 on sine theta is greater than 1 on theta, which is greater than 1 on tan theta. Now here's the clever bit. We multiply throughout by sine theta. Again, sine is positive. We're talking about small angles here. And this becomes sine theta, sine theta, sine theta. These sine thetas cancel out, and you get the 1. Now you get your sine theta over theta. That's the one we want. And then when you 1 on tan theta, tan is sine on cos, so when you flip it becomes cos on sine, and the sines go out. Now, so we have this result that 1 is greater than sine theta on theta, which is greater than cos theta. Now here's the part that's good. As theta goes towards 0, it becomes smaller and smaller and smaller. The cos of theta goes towards 1. Therefore, sine theta on theta must lie between 1 and 1 as cos theta goes towards 1. So the limit of sine theta on theta as theta goes towards 0 is equal to 1. And that's a very, very important limit proof, extremely important, because we're using that to differentiate the sine of theta. Okay, well, thanks for watching.